Hi, we are going to see about graph coloring. Graph coloring in the sense we are going to color the vertices which are being given in the graph. The graph may consist of 2 or n number of vertices, but the main thing we have to see is no two adjacent vertices. That if two vertices are being connected with each other, they are known as adjacent, and they should not be given the same colors. So we have to use M colors. M in the sense it may be 2, 3, 5 depends upon the vertices which are present and that they are being connected with each other. This is also known as M coloring problem. M coloring means the M represents the N. How many colors we are going to use. The color can be noted how means with the degree in the sense if there is a vertex A and we have to check how many connections are there for A. If A has 3 connections, if the vertices is connected to B, C, D, then the degree is known as 3. So we can use D plus 1 colors on it. Suppose if A here we can see A is the, for example, if A is the vertices and degree can be noted as A is connected with B and A is connected with C. So the degree of A is 2. On the same condition, if we are checking the degree of B, so for B it's been connected with A to B. Here it is connected from B to A, then B to C, and also between B to D. So its degree is calculated as 3. So in the sense that we are going to calculate the degree, and the last main thing we have to know is chromatic number. Chromatic number in the sense how least number of colors we are going to use to color the graph. If there may be n number of nodes and the color can be not only in particular thing like 2, 3, 5, it may be n number, but we have to select how least we are going to use. For example, if we have to check the chromatic number, how means if we for the given graph from 1 we are going to check. If I am going to use the number value of one color, that means red, so I cannot on any situation I cannot color this graph because A is being connected with B, C, so they are being interconnected. So so I can't use one color alone. So I'm checking for two colors. Let me choose red and green. So if I giving red here, then I have to give only green here. But B and C are being already connected. So on any case I can't complete the graph with two colors. So there is no probability. So I may choose 3 colors now. Let it be red, green and blue. For assigning this, we have to check frequently the number of colors we are going to use. So on initial stage, we can assign any color. Not only the red, green, blue, we can choose any color as we wish. So in the initial, I am assigning red color. So the probability of A be any color. So here I am going to with red. So I am going to use A as red. Okay. So there will be no use of red and green here. So already from here I have assigned red. Next I am going to B vertices. So default. So there will be probabilities red, green, blue. But here I have assigned red color. So here I can't, for B vertices, I can't assign green color for it. Sorry, red color for it. So the next probability I have is either I have to assign green color or blue color. Next for C also same, or already I have assigned red color there. So the next probability is green and blue. Here for B vertices I can use either green or blue. At the same time C also I can use green or blue. I have to check one thing, not only A and C is connected, B and C is also been connected. So what color I have given to B cannot be assigned to C. Suppose I am using green color for B. So I have assigned B. So in this case I cannot assign green here. So here red, here it's green. So next probability I have is green is not here. So I have only blue for C. Okay, next here three colors are being used. With this we are going to check whether I can complete this entire graph with these three colors. Okay, here for A I have assigned red, for C it's blue, and for B it's green. For D next possibility is red, green, blue. From this I have to check which color which I can give. Already for B it's given as green, so I cannot assign green here. So I have to assign either red color or B color. Sorry, that is blue color. And one more thing we have to see, D is connected to F and D is also been connected to E. So I can either give red or blue. Here the possibility for E is, here for C is it is connected with blue, so I cannot give blue color to E vertexes. So I can give either red or green, here red or blue. So I cannot give red for both D and E because these two vertices are adjacent vertices. So I'm going to give it as red color. It's up to our wish. We can either I can give blue or red, it's up to you. If the entire graph cannot be completed, then we have to backtrack the color and we can assign it. So I'm going with red. So there is no use to blue. So if here it is red, then the next color so for A it is red color, then for B it is blue color, green color, it's for green, and for E also it is green. So as of now there is no adjacent matrix of same color. Final thing is for F we can give either green or blue. So for D it's all red color, so I cannot give red here. Then for E it is green, so I cannot give E. So only option I have is blue. For 6 vertexes we have given 3 colors and the entire graph has been connected. Let me check whether any two adjacent matrix have the same color. It's red, green, blue. So red, green, blue. So as of now the entire graph has been solved with these possibilities. Not only this is not the possibility, we can assign it with any color. Initially we can give green or blue. It's up to you. Here next step we are going to see is state space tree. The state space is the similar thing which we have done is here we are going to see it with tree structure. So for A there is a 3 probability, either it is red, green, blue. For if it may be red, green, blue, whatever we are choosing it. So as I stated earlier, I am going to for it with red. As A vertices is red color, B vertices cannot be red. So the probability is either green or blue. Like this we can choose any other color combinations. For B I have to choose either green or blue in it. I am going to choose green. So there is no probability for blue here. Already red is been cancelled because A vertices has red color. Next, as for B I have assigned green. Here next we have to check for C. I can give red, green, blue, but the condition is C is connected with A and C is also been connected with B. So the color which we are given to A and B cannot be used for C. So for A I have used red, so it cannot be used. The for green is been given to B, so I cannot use green here. So only probability I have is blue for vertices C. Next, from C vertices, I am going to check for D. D, the initial possibilities are red, green and blue. From here, I am going to check whether the D is being connected with it, which vertices. D is connected with B and F, E. So, for E and F, we have not assigned any color yet. So, there is no problem. First, but here the B is given green color and it is being connected to D. So, D cannot be in green color. The either probability is either it can be red or blue. Here we can take either either red color or blue color as we wish. As I am going with red color here, so the blue will be cancelled. Next, main thing for the next I am going to assign for E. For E, it is been connected with three vertices. One is C, one is D and F. F is the we now need to consider the F because it is not yet colored. The the D colored is red. So I cannot give red to E. Okay, I can give either green or blue, but the E connected to C has blue. So I can give only green color to the vertices E. So I am giving green. So next thing is F. F is been connected to D and E. The only probability I have is already it is red, green been used. So I can only give red. I cannot give green as it is connected as red is given to D and green is been given to E. So the only probability I have is blue color. This is the state space tree. The above we have seen the graph and we have assigned the colors. The same thing we have given here, but in the tree structure. In the sense I have chosen red and seen this probability. We can assign green for A or blue. It's up to our wish. Thank you.